Hello friends, in this video I'd like to solve the following problem from the International Mathematical Olympiad 1976, long-listed problem number 40, proposed by the United States of America. Let p be a polynomial. We wish to show that x squared plus x times p of x cubed is not divisible by x squared minus x plus 1. So here are my hints for this problem. First, factorize x squared minus x plus 1 in complex numbers. Use the primitive cube roots of unity. And notice this well-known fact that if we have two polynomials, r divides s, and if x0 is a root of r, then it must be also a root of s. So give this problem a try. Alright, so let's start with noticing that let omega be a complex number such that omega is not 1, but omega cubed is 1. It's one of the two complex roots of unity, cubic roots of unity. Notice well-known fact that 1 plus omega squared can be, or maybe rather, let's write that 1 plus z squared can be factorized as z minus omega squared. Pretty easy to verify that. And furthermore, if I will replace z by minus z, notice that then I will have minus z minus omega squared, but this is the same as z plus omega squared. Alright, so we know that, so in other words, 1 minus z plus z squared has roots minus omega and minus omega squared. Alright, and now let's suppose to the contrary. That x squared minus x plus 1 does divide x squared plus x p of x cubed. Suppose that this is the case. Well, notice that then if I will take this polynomial, if I will plug in minus omega and minus omega squared, we should get 0. So minus omega squared plus minus omega p of minus omega cubed should be equal 0, and at the same time minus omega squared plus minus omega squared p of minus omega squared cubed should also be 0. And let's investigate this system of equations. It says that omega squared minus omega, and here notice that what is omega cubed? Omega cubed is 1, so we have p of minus 1 equals 0. And in the second equation we have omega to the 4th power minus omega squared times p of, well, once again, minus 1 equals 0. Now, from the first equation, we deduce that omega p of minus 1 should be equal omega squared. And let's put it in the second equation. Omega to the 4th power minus omega times p of minus 1, but this is the same as omega squared. So we can factor out omega cubed, omega minus 1 equals 0. And notice that omega cubed is 1, so we get omega equals 1, which is contrary to the fact that omega is not 1. So here we have a contradiction, which says that this means that x squared minus x plus 1 does not divide x squared plus x times p of x. And this closes our proof. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye. Omega cubed, sorry. Omega cubed. Goodbye.